Hello guys, how are you today? So today I'll be explaining the pure mathematics course practice of chapter 2.2. So from this one, we have a couple of questions. We don't have the full quiz. So what are the questions that we do have? Let me just write them down just a second. So the questions that we do have, the questions that we have to do, they are what? They are questions 1, 2, 3, 4, 5, 6, and 7, questions 10, 11, 12, 15, 16, and 17. So these are in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions out of the 19 in total. That means we have 6 that we are not supposed to do. So anyways, let us get started with the first question. What is the first question? It says, fill in the blanks with the correct numbers they want. Okay, this is a big number. 1 plus 2x minus 3x squared to the power of 4. Now, look what is the first thing we're going to do. We're going to separate them into A and B. So this over here is our A, and this over here is what? This is our B. Now, we need to do something because this is in expanded form. It's going to take us so much time. We need to do something called Pascal's triangle. What is Pascal's triangle? Very simply, if you have A plus B, let's write it 4 times. If you have A plus B to the power of 1, 2, 3, and 4, using Pascal's triangle, how are we going to do it? Okay, for every single one, if it's either 1, 1,000, 2 million, 2, no matter what the number is, it will start with 1 and it will end with 1, okay? Now, we move on to the next one. What's happening? You start with 1, you end with 1, but you add the numbers from the top. So 1 plus 1, and it will give you the number in the middle, which is what? Which is 2. Same thing if we continue. 1 in the beginning, 1 in the end. We add, so it's going to be 3 and 3. So 1, 3, 3, 1. Same thing with 4. 1 in the end. Sorry, 1 in the beginning, 1 in the end. Now we add everything. And we're going to have 4, 6, and 4. But we need to which power? To the power of 4. So we will erase everything else and we will keep our answer, which is what? Which is A plus B to the power of 4. Now, what do these represent? These very simply represent the combination. Each one of them is a combination, right? Always in a combination, the n, because this is a combination, nk, the n is what? Is the exponent. So it's 4, 4, 4, 4, and 4. Now, from the k, it will start with 0 and end at 4. So it's going to be 0, 1, 2, 3, and 4. So each of these represent what? They represent the combination of 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. Okay? This is just something extra for you to know why do we do Pascal's triangle. Okay? Now, let us apply Pascal's triangle. We said that it's going to be 1, then 4. I'm going to leave a lot of space because we need this space. Then 6, I think we need a smaller space for 4 and 6. 6, and then 4, and then 1 again. Now we start. What is our A? Our A in this case is 1 plus 2x, okay? Then what's our B? Our B is minus 3x squared plus, we continue, 1 plus 2x minus 3x squared plus 1 plus 2x minus 3x squared, then plus 1 plus 2x minus, this is 1 by the way, 1 plus 2x minus 3x squared, and then finally plus 1 plus 2x, and then minus 3x squared. Now, what are we gonna do? Regarding the exponents, with the A, we start with the number of the power, so we start with the n, which is 4, and we keep on decreasing until we reach 0, so 4, then 3, then 2, then 1, then 0. Now, for B, it's the opposite. We start with the 0 and we keep on increasing until we reach n. And in this case, it's 4. So 0, 1, 2, 3, and 4. So we stop. This is how it's supposed to look like. Now we cancel out anything that's to the power of 0 or 1. So anything that's to the power of 0 and 1. We cancel it out. Okay? Perfect. Now, what do they need from us? They need from us to expand this. Now we have what? We have 1 plus 2x to the power of 4. Guys, please write this down on your copybook because we will need it later. I'm gonna write it down on mine. I will write 1 plus 2x to the power of 4 plus 4 plus 1 plus 2x to the power of 3 times minus 3x squared to the power of 1 plus 6 times 1 plus 2x to the power of 2 times minus 3x squared to the power of 2 plus 4 times 1 plus 2x to the power of 1 times minus 3x to the power of 2, minus 3x squared to the power of 3. And then finally, plus minus 3x squared to the power of 4. Write it on your copybook because we are going to need this, okay? Now, as you notice, we have what? We have for our a's 1 plus 2x to the power of 4, okay? 1 plus 2x to the power of 3, and 1 plus 2x to the power of 2. 1 plus 2x to the power of 2 is easy. You guys should know how to do it. I'll do it later. But now we need to focus on these two. Let us first start with 1 plus 2x to the power of 4. We know, using Pascal's triangle, that what are the values of the combination? They are 1, 4, 6. I don't think it fits. 1, 4, 6, 4, and 1. Now, what do we do? Same thing as we did before. This is our A, this is our B. We're gonna write AB plus AB plus AB. This is plus here. AB, A is 1, plus AB, right? Now, we start with the exponents. Always, A will have the exponent of n, so 4, and it will decrease until it reaches 0, so 4, 3, 2, 1, and 0. Whereas for B, it's the opposite. You start with the 0 and you increase until you reach 4, so 0, or until you reach n, so 0, 1, 2, 3, and 4. Okay, perfect. Now, you remove anything that is to the power of 0 and you remove 1. You remove anything that's to the power of 0 and you remove 1. Now, we keep this 1 over here. It's very important to keep it. Why? Because it's added. It's not multiplied, it's added. So if it's multiplied, you can remove it, but here in this case, you cannot remove it. Why? Because it's added, so you will keep it. Now, for all of the other ones, you can remove them because 1 to the power of anything is 1. And 1 times anything is the number itself. So there is literally no use for the value of 1. So now it's what? It's 1 to the power of 4, which is 1. Here, 1 plus 4 times 2x, that's 8x. Plus 6 times 2x squared, this is what, 4x squared now, is going to be 24x squared, plus 4 times 2x to the power of 3, 2x to the power of 3 is going to be 8x cubed. So 4 times 8 is 32x to the power of 3, plus what? 16x to the power of 4. So now what will we do? We'll erase all of these, okay? And please, on your copybooks, or on a piece of paper, I'm writing on my copybook, write the value of what? Write the value of 1 plus 2x to the power of 4. It is what? 1 plus 8x plus 24x squared plus 32x to the power of 3 plus 16x to the power of 4. Perfect. Just like that, we finished what? We finished 1 plus 2 to the, 1 plus 2x to the power of 4. Now that we finished with to the power of 4, let's move on to 1 plus 2x to the power of 3. What are we going to do now? We're going to use Pascal's triangle. If you remember, you can do it on a paper, okay? But the values from Pascal's triangle for 3 is 1, 3, 3, and 1. So let's give some space. So 1, 3, 3, and 1. Now what do we do again? You have our A and we have our B. So we do AB, this is 2x, plus AB plus AB plus AB. Perfect. Now again, our exponent is 3, so we start from 3 for the A and we descend. So 3, then 2, then 1, then 0. Whereas for the B, we do the opposite. We start from 0 and we increase until we reach n. So 0, 1, 2, and 3. Now, you cancel out anything that's to the power of 0. And that is 1. This one, we keep it because it's added, not multiplied. Remove anything to the power of 0 and 1. Now, anything, to the power of anything is what? It is 1. So there's no need for this. We only keep this because it's added, not multiplied, right? So no need for this either. So let us do it. We will have 1 plus 3 times 2x, that's 6x, plus 3 times 4x squared, that is 12x squared, plus what? Plus 8x to the power of. Now, before we jump into conclusion of, oh, okay, this is directly our answer, we have to look back on our paper. What did we write on the paper? We wrote on our paper 4 times 1 plus 2x to the power of 3 multiplied by minus 3x squared to the power of 1. So it's what? 4 times the answer times minus 3x squared. So you can directly multiply 4 times minus 3x squared to get minus 12x squared. And now, what can you do? You can multiply the full answer by minus 12x squared. After multiplying the full answer by minus 12x squared, what are we going to get? We are going to get minus 12x squared plus 6 times 12 is 72, minus 72x to the power of 3 minus 144x to the power of 4 minus 96x to the power of 5. Okay, now this is the final answer of what? Of 4 times 1 plus 2x to the power of 3 times minus 3x squared to the power of 1. Please write it down. Minus 12x squared minus 72x to the power of 3 minus 144x to the power of 4 minus 96x to the power of 5. Now, the next one is pretty easy. What is the next one? The next one is 6 times 1 plus 2x to the power of 2 times minus 3x squared to the power of 2. What do? We just expand this. If you don't know how to expand this, you really should practice because it's very important. This is going to be 1 squared plus 2 times 1 times 2x plus 2x squared. So we will get what? 1 plus 4x plus 4x squared. Remember, it's multiplied by 6. So when you multiply by 6, it's going to be what? It's going to be 6 plus 24x plus 24x squared. Now, all of this is multiplied by minus 3x squared to the power of 2. Okay? Anything to the power of an even, you will cancel what? You will cancel the minus. So now it's plus 3x squared to the power of 2 or plus 9x to the power of 4. That means now you need to multiply everything by what? By 9x to the power of 4. But I'm going to stop for a second. I'm going to say, okay, let us calm down. By now you guys should know how to continue multiplying the rest. If we multiply all of this by x to the power of 4, to which power exponent will we have? We will have to the power of 4, which is the minimum. Then we'll have x5 and x6. But they told us to stop where? They told us to stop at x to the power of 3. So, because they told us to stop at x to the power of 3, I am gonna stop the full solving from here. And we're only gonna keep the ones that we solved from before, which is 1 plus 2x to the power of 4, plus 4 times 1 plus 2x to the power of 3, times minus 3x squared to the power of 1. Right? Why? Because if you multiply the rest, you're gonna get exponents that are all bigger than x to the power of 3, and we don't need anything bigger than x to the power of 3. So now, I really hope that you understood why we stopped, because we cannot take anything higher than x to the power of 3. Even though, and when we were solving, we got x to the power of 4, that's fine. But when we were solving, the one that we were solving like 10 seconds ago, we got x to the power of 4 being the least possible value, and this is not what we need. We need the least possible value to be at maximum x to the power of 3. So since it's x to the power of 4, we are not able to continue solving, and this will save time for us as well. So now we'll take the answer of what? Of 1 plus 2x to the power of 4 plus what? Plus 4 times 1 plus 2x to the power of 3 times minus 3x squared to the power of 1. And you just add. So let's go back to what we wrote. For this one, what was the answer? The answer was 1 plus 8x plus 4x squared. So 1 plus 8x plus 24x squared plus 32x to the power of 3. Do we include 16x to the power of 4? No, because we don't need anything to the x to the power of 4. Now, this one, what was the answer for this one? The answer for this one was minus 12x squared, okay? Minus 72 x to the power of 3. Do we continue? Do we put minus 144 x4 minus 96 x5? No, because the maximum we need is x3 now. Perfect. All we need to do is to add Now it's going to be 1 plus 8x plus 12x squared minus 40x to the power of 3. If you're asking how I did it mentally. You guys can do it on the calculator. So this is what this is supposed to be our final answer. So our final answer is what is 1 plus 8x plus 12x squared minus 40x to the power of 3. So 1, 8, 12, and minus 40. Let's move on to the next part, which is question number 2. We have question number 2. What does it say in question number 2? In expanded form, a plus b to the power of 4 is equal to a4 plus 4a3b plus etc. etc. Now, important thing here. There's so many ways to do this. Now, if you want to be smart, okay, and you want to solve this in like 3 seconds, look what you will do. We know that a decreases as we go down. So it's 4, 3, 2, 1, 0. And then b, it increases 0, 1, 2, 3, 4. There we go. This one is done. Now, what do we also know? We also know that the values next to a and b, they are what? They are the combination. So this is 4 combination 0, 4 combination 1, 4 combination 2. If you put it on the calculator, you will get an answer of 6. 4 combination 3 and 4 combination 4. Okay, this is one way to do it. Let us say, however, they gave it to you in the computer part, right? And they did not give you any of these. How are you gonna do it on the computer part? And they didn't give you any of these. You just need to write it yourself. Very simply, you will use Pascal's triangle. You know how to do Pascal's triangle. You can do it for yourself. And you will get that a plus b to the power of 4 is gonna be what? It's gonna be 1, 4, 6, 4, 1. Now you write ab plus ab plus ab plus ab plus ab. Now, as we said, we start with 4, or we start with n from a all the way until 0. So 4, 3, 2, 1, 0. For b, it's the opposite. We start with 0 and we go up until n. So 0, 1, 2, 3, 4. Now, anything to the power of 0, we remove it. And 1, we remove it as well. So we are going to be left with what? With a to the power of 4 plus 4a3b1 plus 6a2b6, plus 6a2b2 plus 4a1b3 plus b to the power of 4. This is on the computer part if you want to save time. However, very important, if they told you to write like fully expanded form, I don't think you're supposed to be using Pascal's triangle. What will you do in this scenario? In this scenario, you will use what? You will use this equation, which is what? nk combination times a n minus k b k. Very important. So you just write this equation on top, okay, in the written part. So let me write written. You write this equation on top, and then what do you do now? You have a plus b to the power of 4. You start 4, and always you start with 0 in the bottom. Whatever n is, you start with 0 at the bottom. 4, 0. Then a, you just need to write this equation on top, then trust me, it's gonna be fine. Then you can start ab plus 4, 1, ab plus 4, 2, ab plus 4, 3, ab plus 4, 4, ab. Then you go again from n and you decrease. So 4, 3, 2, 1, 0. From 0 and you increase all the way till n. So 0, 1, 2, 3, and 4. Now anything, anything to the power of 0, you will remove it. And one thing to know, if you have n0 or nn, they will both be equal to what? They will both be equal to 1. So this is equal to this, it's equal to 1. So that's why you don't really need to put them. You can remove them and you can write it like this in the written part, okay? So for this one, what is the answer? For this one, the answer is 6 and 3. Let's move on to question number 3. What did they say in question number 3? Okay, here they want it in expanded form. I explained to you already in the previous questions how do we do it if it's like a big expanded form number. How do we do it if they want it in Pascal's triangle, if they want it in the written part, if they want it in the computer part? In the computer part, we said that it is better to do it using what? To do it using Pascal's triangle. Now, we did until 4 before. So what were the values for 4? They were 1, 4, 6, 4, 1. Now, all we need extra is 5. How do you get 5? So this is what? A plus b to the power of 4. How do you get a plus b to the power of 5? Very simply, 1 3 in the beginning, 1 in the end. Then you add. And then what do you get? You get 5, 10, 10, 5. So it's 1, 5, 10, 10, 5, and 1. These are very simply the values of the combination. Okay? And so now we start. It's 1, 5, 10. So 1, 5, 10, 5. My bad, it's not 10, 5. It's 1, 5, 10, 10, 5, 1. Now we start. AB, this is our A, this is our B, times 2 minus 6x, minus x squared, plus 2 minus x, put the squared inside, not outside, plus 10 times 2 minus x squared, plus 10 times 2 minus x squared, plus 5 times 2 minus x squared, plus 1 times 2 minus x squared. Now what do we do again? For A, we start with the n and we decrease all the way until 0. So 5, 4, 3, 2, 1, 0. For B, we start with 0 and we increase all the way until n. So 0, 1, 2, 3, 4, and 5. Now anything with 1 or to the power of 0, we can cancel it. And we will be left with this. Now all you need to do is solve it. It's gonna be 32 plus, so 32 plus minus 80 x to the power of 2 plus 80 x to the power of 4. And then this one is how much? This one is minus 40 x to the power of 6 plus this is 10x to the power of 8 minus 10x to the power of, not minus 10, minus x to the power of 10. So what is the final answer? Let's erase everything in the middle. Our final answer is 32 minus 80x squared plus 80x4 minus 40x to the power of 6 plus 10x to the power of 8 minus x to the power of 10. So let's do it backwards. 32 minus 80x squared plus 80x4 minus 40x6 plus 10x8. And yeah, that's pretty much our answer. Now let's move on to question number 4. We also have question number 4. Now, what is the coefficient of the x5 term in the expansion of this? First thing we do, we check which of them, A and B, this is our A and this is our B, which of them has x? In this case, only A has x. That means what? That means A, in this case our A is 2x, is gonna be raised to which power? To the 5th power, okay? It's 2x to the 5th power, okay? And we know that if we're looking for the x5 term, there's also gonna be a combination with it. Why? Because what's the question? Or what's the general rule? It's nk times a n minus k bk, right? So nk, in this case our n is 7 and our k we need to find it. Then our b in this case is minus 1 over 4. What will be the exponent of minus 1 over 4? It's gonna be 2. Why? Because 7 minus 5 is 2. And that means our k is 2. So this is 2 over here. Now all you need to do is to put it on the calculator. You're gonna get 7 combination 2, which is going to be 21, times 2x to the power of 5, which is 32x5, times minus 1 over 4 squared, times 1 over 16. You'll multiply it all and you will get an answer of 42x to the power of 5. So this is what? This is our final answer. So the coefficient of the x5 term is what? Is 42. Now we move on to question number 5. What does it say in question number 5? What is the coefficient of the term x10 in this expansion? Now, which of them, A and B, has x? As you can see, they both have x. So in the case that they both have x, and only in this case, this is what we're gonna do. We're gonna do x10, okay, is equal to what? Is equal to x4, right? This is our A, by the way, to the power of n minus k. Our n in this case is 5, to the power of 5 minus k multiplied by what? By minus 3 over x. Let me just put this down. Minus 3 over x to the power of k, right? Now, look what we're gonna do. whenever we have x in the denominator, we refuse to keep it in the denominator. Instead, we put it up in the numerator and we change its sign to x to the power of negative 1, okay? Now, look what we are gonna do in this case. We're gonna get rid of all of the x and including the number with x, okay? And we will solve it as if we're solving an inequality, or not an inequality, an unknown variable equation. So, 10 is equal to 4 times 5 minus k. Now, minus 1 times k is what is minus k. Perfect. Now expand. 10 is equal to 20 minus 4k minus k. So move 20 to the other side. Minus 10 is equal to minus 5k. That means k is equal to 2. Perfect. Now we have the value of what? We have the value of k to be what? To be 2. Now, we bring back the old equation that we had over here. And we return everything back to normal. So x to the power of minus 1 becomes what? 3 minus 3 over x. And now we substitute what? We substitute the k with 2. Perfect, perfect. But is this what we want? No, we want the coefficient of the x10. So we have what now? If the equation is nk, an minus k, bk, what are we missing? We are missing, very simply, the combination, which is nk. So in this case, it's what? 5, 2, because k is 2. All right, now perfect. All we need to do is expand. 5, 2 in this case is 10, if I'm not mistaken. Yeah, it's 10 times, here, 5 minus 2 is 3. X to the power of 4 multiplied by, x to the power of 4, all of it to the power of 3 is x to the power of 12, because you will multiply the exponents. And then here you will square up and down, so you will get 9 over x squared. Now, x to the power of 12 divided, not to the power of, divided by x to the power of 2. Here it's like doing, it's the same as doing 12 minus 2. So you're gonna get 10, but don't forget to put x. So now it's x to the power of 10. And very simply, as we're looking for what? We're looking for x to the power of 10. So this will go away, and this will become x to the power of 10. Now, you just need to multiply everything, and you will get 90 x to the power of 10. Let's move on to question number 6. Question number 6 is pretty easy. You can do it on your calculator, akid. So on the calculator, I will just tell you shift log, this type of log, which is small and then big, like this. Okay, you will get the summation. On the top, you're supposed to put 6. On the bottom, you're supposed to put x is equal to 1. And here's the nice part. You will have brackets, right? Now, what are you going to write in the brackets? You will write 2, and you will put what? You will put x. How do you put x? Very simply, you will choose alpha, and you will find where is x. For me, x is in this bracket. You will do alpha this bracket, and you will get what? You will get x. So, 2x times, open bracket again, x plus 1. Put this all in the calculator, and you're supposed to get your answer. Now, if you don't have this option on your calculator, what are you gonna do? Very simply, you have from 1 till 6. That means you're gonna substitute 1, 2, 3, 4, 5, and 6. Amazing. Where will you substitute them? Instead of I. So it's 2 times 1 plus 1. Plus 2 times 2 times 2 plus 1. Plus 2 times 3 plus 1. Plus 2 times 4 plus 1. Plus 2 times 5 plus 1, and then finally plus 2 times 6 plus 1. You can do it on your calculator. I'll just do the sigma notation. So 6, 1, 2, x, open brackets, x plus 1, close brackets, and you will get an answer of what? Of 224. So our answer is supposed to be what? It's supposed to be 224. Let's move on to question number 7. What does it say? Now, in question number 7, they're saying, what is the coefficient of the x5 term in the expansion? Okay, we have our a over here and our b over here. What do they need? The coefficient of the x5 term in the expansion. So, where do we have x? In a or in b or in both? We have it only in a. That means a, which is x, is going to be to the power of 5. And b is going to be to the power of 2. Why? Because it's 5 plus 2 is going to give us 7, which is n. Now, we need to add the combination. What's the combination? It's 7 and 2. Why? Because our n is 7 and our k is 2. Now, all you need to do, this is which question again? Question 7. All you need to do now is to expand. So 7 combination 2, do it on your calculator, you'll get 21. Okay? 21 times x to the power of 5 times 4. You're gonna get very simply 84 x to the power of 5. So the coefficient is what? The coefficient is 84. Now, do we have question 8? No, we do not have question 8. Let me just check again what are the questions we have. We did 1, 2, 3, 4, 5, 6, and 7. We don't have 8 and 9. We have 10. 10, 11, 12. We have them now. Okay, perfect. This came in the AMS before. Given that, whatever this is, what whole number is equal to the summation of 20k equals to 1, 2k squared minus 3k plus 2. So I'm going to do it in a way. Of course, if you have the calculator, you can put it on the calculator. Right? Put it right now and get the answer. So 20 is on top. X is equal to 1. Now, 2x squared minus 3x plus 2. And you're supposed to get an answer of 5150. This is supposed to be our answer. Now, if you don't have this option on the calculator, how are you going to do it? Very simply, you will take it like this. You will take out each value by itself. So now, it's the summation 20k equals to 1, 2k squared, minus summation 20k equals to 1, actually without the minus, plus minus 3k. And then summation 20k equals to 1, you will get what? You will get plus 2. Now, what do we need to do in this scenario? In this scenario, if you have something with a variable, you will take out the number. Let's take out the number. So it's going to be 2 summation 20k equals to 1, k squared, plus minus 3, so basically minus 3, summation 20k equals to 1, k, okay? Now, plus, this does not have a variable. Since this does not have a variable, if you remember one of the rules, because it's a whole number here, very simply, what you can do is you can take n, which in this case is 20, and you can multiply it by 2. So 20 times 2 is what? It is 40. Now, what do we need to do? We need to substitute each one by, actually wait, without erasing, we need to substitute each one by their value. So this is the same as, which one is the same as this one? And this, it's the same as this one. So all we need to do is to substitute them in their values. So let's erase. Again, our n is how much? Our n is 20, okay? So this is going to be 3 times 20 times 20 plus 1 over 2. And this one, you're going to erase it as well. And don't forget to put 20 instead of n. It's going to be 20 times 20 plus 1 times 2 times 20 plus 1 over what? Over 6. 2 times 20 plus 1 over 6. There we go. Okay. Now, put it on your calculator. Let me put it on my calculator. It's going to take me a bit, so please wait. 2 times 20 times 20 plus 1 times 2 times 20 plus 1 over what? Wait, actually, there's no extra bracket. Over what? Over 6, okay? Minus 3 times 20 times 20 plus 1 over 2. And then plus 40. Do not forget the plus 40. If you get 5150, then it's correct. It's the same as this one over here. Let's now move on to question number 11. Very nice. What is the coefficient of the 1 over x3 term in the expansion of this? Now, again, let's separate our a and our b. We have a over here, b over here, right? Now, they need 1 over x to the power of 3. We said if we ever have x in the denominator, we will take it up to the numerator. So, it's x to the power of 3 in the denominator. In the numerator, it will be x to the power of negative 3. Okay, perfect. Now, both our a and b have x. So, we'll need to use the equation we used before, which is what? Which is x minus 3 is equal to what? Is equal to our a, which is x over 3. Okay? To the power of n minus k, our n in this case is 7, so 7 minus k, okay? Times 3 over x. Remember, if we have x in the denominator, we don't accept it. We have to put it up in the numerator, so 3 times x minus 1 to the power of what? To the power of k. Now, what did we say we would do? We remove all the value, or like whole number with x, and we get rid of what? We get rid of like the base, and we only keep the exponent. So what's the exponent in this case? It's minus 3 is equal to 7 minus k, then minus 1 times k is minus k. So move this to the other side. Minus 10 is equal to minus 2k. K is then equal to 5. Perfect. Now we have the value of k. You'll erase this for more space. Now what do? We substitute k with what? With 5. Now, what did we forget to do? We forgot to put the combination. What's the combination in this case? It is 7, 5. So let's put it on the calculator. It's supposed to be 7 combination 5, which is what? Which is 21, times this 7 minus 5 is 2, x squared over 9 times what? Here I forgot to return it back to normal. Always return it back to normal. So 3 to the power of 5. What's 3 to the power of 5? It is 243 over what? Over x to the power of 5. Now we solve it, okay? Here, x2 and x5, the x2 will go and the x5 will become x3. Now we do 21 times 243 divided by 9, and we'll get an answer of what? So we will get an answer of 567 over what? Over x to the power of 3. Or you can write it in another way, which is what? Which is 567 times 1 over x to the power of 3. It's the same exact thing. So what's the coefficient? It's 567. So we did 10 and 11. What do we still have? We still have 12 from this group. 10, 11, 12. What is the constant term? Aha, when they say constant term, what do they mean? They mean x is to the power of 0. So let us solve. X to the power of 0. A and B, both of them have x. So what are we going to do? We're going to make them equal. x0 is equal to a to the power of n minus k, so 6 minus k, okay, times b, which is 1 over x to the power of k. Now, look what happened. We have x in the denominator. Because x is in the denominator, we'll have to move it up. It becomes x to the power of minus 1. Now we remove everything. I think I made this too small, 1x. Now we remove everything, right? And what will we have left? We will have 0 is equal to 2 times 6 minus k minus k. So 0 is equal to 12 minus 2k minus k. Move 12 to the other side. Minus 12 is equal to minus 3k. Then we divide by minus 3 and we get that k is equal to 4. Now we have the value of k. We'll be able to substitute it, right? So now we replace k by 4. Okay? And I forgot that we have to return the x minus 1 to how it was originally. Now, what are we missing? We have everything. 6 minus 4 is 2. What are we missing? We have everything. Right? So since we have everything, the only thing we're missing is what is the combination. So it's going to be 6 and 4. Okay? So, where is it? 5, 6. Here we go. So it's going to be what? It's going to be 6 combination 4, which is 15, times 2x squared to the power of 2, so that is 4x to the power of 4, times what? 1 over x to the power of 4. This and this will cancel, and we're left with 1 times 4 times 15, and you will get an answer of 60. So the constant term in this case is what? Is 60. Now, we don't have 13 and 14. We have 15, 16, and 17, and we are done with this quiz, okay? So, in the binomial expansion, used to approximate the value of 1.02 to the power of 6, the first term is 1, and the fourth term is this, where a is an integer. What is the value of a? Now, in my opinion, when you see a number like this, okay, think, what is it easy to separate it into? You will come to where is the decimal place? Here, and you will separate the numbers like this. So you have 1 plus what? 0.02. Perfect. You separated them. So you always come to where the decimal place is and you separate them. 1. And instead of the 1, you put a 0. So 0.02. All of it to the power of 6. Now we have what? We have our A. And we have what? We also have our B. Now, in this case, they want us to find out the fourth term. Do you want to use Pascal's triangle? It's up to you. Let us use Pascal's triangle. If you remember, we did A plus B to the power of 5. What was it? It was 1, 5, 10, 10, 5, 1. Now we need to do what? We need to do a plus b to the power of 6. What do we start with? We do 1 outside, like 1 in the beginning, 1 in the end. And then we add 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 5 plus 10 is 15. 5 plus 1 is 6. So it's gonna be 1, 6, 15, 20, 15, 6, 1. But which term do they need? They need the fourth term. So this is 1, 2, 3, and 4. 20, okay? And it is what? It is the fourth term. Now, what I prefer to do is to write the first three. So 1, 6, 15, and 20. We stop at the fourth term, okay? Now, what do we do now? We multiply by a and b. So what is our a? Our a is 1, our b is 0.02, plus 1, 0.02, plus 1, 0.02, plus 1, 0.02. Now what do we do? With our a, we start with the n, which in this case is 6, and we decrease. So 6, then 5, then 4, then 3, okay? Whereas for b, we do the opposite. We start with the 0 and we increase all the way to n. So 0, 1, 2, and 3. Perfect. Now we have the fourth value, right? We have the fourth value, and we have what it is entirely. Now it's 20 times 1 to the power of 3, which is 1. And then 0.02 to the power of 3, it is what? It is 8 times 10 to the power of 6, which is this one. Let me just check. 1, 2, 3, 4, 5, and 6. Yeah. So this is what? This is 8 times 10 to the power of 6. Or in another term, 0.000008. So what do we have over here? 1. Anything times 1 is the number itself. You don't need it in this equation. So we have 0. Whatever, how many zeros? 8. And we need the value of a. So what is the value of a that we got over here? 20. So the answer is what? The answer is 20. Now, we finished 15. We'll move on to 16. Okay, I love this question. It's very nice. It's very fun. So, using the sigma notation, 1 plus 3 plus 5 all the way to 101 can be expressed as. So, look, we have a number n over here, right? So, we have the initial number, or the first number that we will substitute in t, right? This is always going to give us the first digit. So, 1 is equal to 2 times 0, which is the first number we'll substitute in t, plus, let's call this x. Anything times 0 is 0. So, this goes. And then, basically, you will get that what? That x is 1. That means the value over here is 1. Now we have what? We have the value of the box to be 1. We need to find the value of n. The value of n, we will substitute it in what? It's the last digit you will substitute in t. And the answer will give you what? The last digit of the summation. So 20, 2 times, not 20, sorry, 2 times n, okay, plus 1 is equal to 101. Move this to the other side. 2n is equal to 101 minus 1, which is what? 100. So n is equal to 50. Very simply. 50 and 1. Now the last question I'll be doing for this quiz is question 17. Now this is really easy. Oh my goodness, the easiest question I have ever seen. What will you do? You have I 5. I is 1 all the way until 5. That means in I you will substitute 1, 2, 3, 4, and 5. But it's I squared, so what is it? It's 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Perfect. What is this? It's this answer. So this is our answer over here. I think these are the only questions we needed to do. Let's submit and hopefully we got them correct. Let's pray that we got them correct. Now let us see. Perfect. As you can see, the only ones we didn't answer are the blue ones. And everything we did answer are green. So perfect. We don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day. Let's just submit to double check. Plus. Plus minus 10x squared plus my dad